All right. Hi, guys. So this is for Module 7 for the study guide. And today we're going to be looking at just basically our good old-fashioned review. So if we look at number 1, you'll see that we have to fill in the blanks to complete the proof of the triangle sum theorem. Again, the triangle sum theorem basically says that all the interior angles of a triangle have to add up to 180. They tell us that basically we have triangle ABC here. All right. Again, triangle ABC. And then the first things first is they draw a line through point B, okay, right here, labeled L, okay, and it's parallel to AC. Okay, again, those little marks mean they're parallel. So this is the parallel postulate. Now, basically, angle 1 should angle or equal what other angle? So if you look here, angle 1, well, we learned about parallel lines and a transversal cutting through, and I see that angle 1 and angle 4 are alternate interior angles. That means they are congruent. So the measure for angle 1 should be the same as the measure for angle 4. Now, for angle 3, all right, it should have the same measure as angle 5 because of also the alternate interior angle theorem. Okay, so that's a blast from the past, always coming back. All right, so we have that idea, and we know that basically the measure for angle 4 plus the measure for angle 2 plus the measure for angle 5, and again, we're talking about these three guys right here, all have to add up to 180 because they all share the same side. They are all linear pairs of the line L that we created. And we know that every line has 180 degrees. That is the angle addition postulate and definition of a straight line. Okay, for the reasoning. Now, didn't we say that the measure for angle 1 is the same as angle 4? So instead of a measure of angle 4, technically this is the measure for angle 1 plus the 2, okay, plus the measure of angle 5, but didn't we say the measure of angle 5 was the same as measure 3? Well, voila, this is good old-fashioned substitution. Very nice. Okay, so let's scroll down. And let's go ahead and start with the next set of problems. So now we have to look for some angle measurements. So let's go ahead and do this. We have an exterior angle, angle ACD. I call it ACD because you want to make sure you're specifying that it's the exterior angle. If I was to call it angle C, it's like, well, which one? Are you talking about the angle C in here or the angle C out here? So really, I'm telling you this is angle ACD. And we know the angle ACD should equal the sum of the two interior angles, angle A and angle B. All right, so those two added up should be equal to the exterior angle. So again, that's angle A plus angle B. All right, so let's go ahead and substitute in those values and I'm going to use the symmetric property real quick. So angle A again was 2z plus angle B, which was 5z plus or minus 2, sorry. And it all has to equal the exterior angle, which is 145 degrees. That was given. Okay, so combine like terms. We have 7z minus the 2, still equaling the exterior angle, 145 degrees. And we're going to use the addition property of equality. Get some cancellation there. And we got 7z equaling 147. Good old-fashioned division problem. Okay, division property, and we should get z equaling 21. But was that what they were asking for? No, it's for the angle, for the measure for angle B, this guy. All right, so we're going to use his expression to substitute in our z value, which is 21. So we have 5z, which is really just 21. So 5 times 21 minus the 2, and that'll get us 105 minus the 2. So we got 103 degrees for the measure of angle B. All right, good stuff. All right, so in part B, if the exterior angle drawn measures 150 degrees, again, they're talking about angle DFG, is 150, and the measure of angle D is twice that of E, which we don't know, so I'm going to represent as X. And again, angle D is twice that, so 2 times X, which we don't know. Now we have to find the measure of the 2 remote interior angles. Okay, well, we know, well, we don't know angle E. All we know is that angle D is 2 times more, so I used variables to represent that unknown quantity. But basically we have this. We have a 2x plus an x. Okay, these are the interior angles. And it has to equal the 150. I'm just going to go ahead and combine like terms. And division property. And I get x equals 50. Very nice. I'm going to go ahead and substitute them in. So the measure for angle E is 50 degrees. The measure for angle D has to be 2 times more than E. So 2 times 50 is 100 degrees. And that makes sense because 50 plus 100 checks out, 150 degrees. All right, so part 3, question A, solve for y. Nasty fractions, just stay with me on this. Don't be scared of fractions. This is an isosceles triangle. I'm sorry, equilateral triangle. Silly me. Here I am losing my mind. There we go. So this is an equilateral triangle. Why do I know that? Is because equiangular, I believe it is referred to. All 3 angles are the same. Therefore, it has to be an equilateral triangle. And what we know about equilateral triangles is that all their sides are the same. So AB should be congruent to AC. All right, so we're going to set them equal to each other. So we have, again, AC is congruent or equal to AB. And that's the idea that we use to set up our math. So we have 4/5 y minus 1 equaling 3/10 y plus 9. We're going to go ahead and use the addition property of equality to start isolating our values. Again, I'm just keeping the fractions over there. Fraction here. And we got this plus 10 because of that 9 plus 1. Now we actually have to subtract the 3/10 y to both sides because we want our variable on the left-hand side. So we end up getting 4/5 minus the 3/10 with our fractions, but they all belong to y, so I'm just going to write it this way so you can kind of see what's going to happen with the fractions. Okay, equaling the 10. All right, so for fractions we need a common denominator. I know that 5 and 10, when you basically want them to have the same common denominator, I'm going to multiply the 4/5 by 2. Okay, and what you do to the bottom, you have to do the top. So when I do that, 2 times the 4 is going to get me the 8. And the 2 times the 5 is going to give me the 10. And basically, I just rewrote 4/5. All right, it's basically all I did. And we got that minus 3/10 right here. And again, this is for all the y. And it's still equaling the 10. All right, 8 minus 3 on the numerator is 5. Very nice. And we got that 10 still. So that's what we get for our new fraction. And what's nice is we already know that 5/10 is just a fancy way of saying 1/5. So let me write that as soon as I get done with this computer. And we're still equaling 10. So again, I'm going to simplify over here. 5/10 is really just 1/2. And we're still equaling 10. What's the opposite of dividing by 2? Multiplying by 2. But just remember what you do to one side, you have to do to the other. So not only are you multiplying 2 times the 1/2, but you're also going to multiply the 2 times that 10. And you should get y equals 20 for your answer, for your variable. All right. So again, set them equal to each other because that is the idea of the equilateral triangles. All right, solve for measurement D. This is an isosceles triangle, all right? It doesn't specify if it has the same, all 3 sides, but it only gives you the 2 sides, and that's what iso means. All right, so isosceles triangle, all right? That means 2 sides are the same, and we know that their 2 sides have the same base angle, which is right here and right here. Okay, that means there are technically 2 4x plus 1s because their base angles have to be the same, and if one base angle's expression is 4x plus 1, there's another angle with the same expression. So again, we all know that all the interior angles of a triangle have to add up to 180. So we're just going to go ahead and combine all the angles together. Let me see if I have enough room down below. There we go. That's way better. Okay, good. All right. So again, we're going to have angle F, which was 5x minus 4, plus the 2 4x plus 1s. And we all know that should equal 180 degrees. Now you could have added just 4x plus 1 plus another 4x plus 1. I decided to write 2 4x plus 1s because there are 2, right? 2 base angles. All right, so I'm going to go ahead and distribute. I got this 5x minus 4 and distribution. All right, multiplying that 2, okay? So we got 2 times 4x, which is 8x. We got 2 times 1, which is just 2. And still setting up to 180 degrees, combine like terms. So that should give us 13x. And negative 4 plus 2 is negative 2. And we're still equaling that to 180. Addition property of equality. And we should have 13x equaling 182 degrees. Division property, because again, we're trying to isolate the variable, which is x. And then lo and behold, we have, let me see if I can do this in my head real quick. 1, there's a remainder of a 5, and I'm going to say 4. Yep, so 14. Okay, so let me double check that in my head real quick. 18 divided by 13 is 1, remainder of 5, carry the 5, and 4. Yep, I'm good. Okay, so x equals 14, but that's not the answer. They were looking for the measure of angle D, and D is 4x plus 1. So x we said was 14, so 4 times 14 plus the 1. 4 times 14 is 56. Yep. And 56 plus 1 is 57. So the measure for angle D equals 57 degrees. Oh yeah. All right, so moving on. we have, let's see, number 4. Okay, so triangle inequality and all that good jazz. Determine if the triangle can be formed with the given side lengths. Explain your reasoning. Okay, so remember with the triangle, um, two sides added up together have to be greater than the third side. So we're going to test the 12-sided leg plus the 4-sided leg, and it should be greater than the third leg, which is 17. But as you can see, 16 is not more than 17. That is false. Okay, so no, you can't form a triangle with these measurements. Okay, why? Because if you try to add up two of the given sides, you get a false statement. Okay, so no, that won't work. Let's try the next one. We have 24 plus the 8 centimeters, and that should be greater than 30. And that looks like that checks out. 32 is definitely greater than 30. Let's try the other combination. We have 8 plus 30, and that should be greater than 24, which checks out. 38 is definitely greater than 24. That is true. And lastly, the next combination is 24 plus the 30. And again, that has to be greater than 8, right? And that's definitely true. We combine them. 54 is definitely greater than 8. So yeah, all three situations check out. So yes, you can construct a triangle with those measurements because your inequalities are all true, no matter which situation. All right, so number 5. This is a regular hexagon, good stuff. And basically what we're going to do here is we're going to solve for x and y. So again, this is for x and y. All right, so it's a hexagon. That means we have 6 sides. And the thing about hexagons or, polygons or heptagons or any of those kind of gongs that are just perfectly wonderful is that all their sides are congruent. That's something to note. Um, and therefore, if you actually notice the darker shaded regions of this hexagon, okay, you actually have two isosceles triangles staring at you. So we're actually using the idea of hexagons with isosceles triangles, and we're going to blend in some angles pretty soon here. All right, so a hexagon is 6 sides, all right, otherwise known as a sixagon. We have a formula to find out what the interior angles are for a hexagon. So basically, again, we're going to use this formula, n minus 2 times 180 degrees. All right, so we have 6 sides, so 6 minus 2 times 180, and that is going to be 4 times 180. That's 400 plus 32, so that should give us 720 degrees. Let me double check that in my head real quick. Yeah, that checks out. Okay. Now the thing is how many angles do we really have here? We have 1, 2, 3, 4, 5, 6, and all 6 of these angles have to be congruent to each other. That's like one of the properties of a hexagon. Okay. So, oh, look at that. We actually already found out the value for y. Okay. If we divide by 6 angles, we get 20. Yeah, 120 degrees. So y equals 120 degrees. All right, nice. So again, this was because we had 6 sides, and this is the total of the angles. Okay, and we had to use this formula up here. All right. Now, so we got y equals 120. We know that this triangle right here is an isosceles triangle. That's an ISO. That's an isosceles triangle. And don't we know that this angle right here is congruent to this angle right here? And if that's the case, we need to know those angles because we want to find x. So we know we have 2 angles. We'll call them, we're not going to call them x because x is representing something else in this situation. But we have 2 angles. I'll use A. How about A? A. All right, so we have 2 angles. plus the 120, and it has to equal the 180 because the triangle sum theorem, right? So basically, we're going to use a subtraction property. I'm going to figure out what my other two angles are. Sorry, subtraction property right there. And I'm going to get 2a equals 60, division property, good stuff, and a equals 30. Good. So this guy's 30 right here. This guy's 30 degrees right here. And fun fact, because the whole congruency idea, these two isosceles triangles are congruent, and you should know why. Side, angle, side, right? So again, these two triangles are congruent, so be aware of that. And that's why I'm going to say right now, because of CPCTC, this angle is also 30 degrees. Now, if that guy's 30 degrees and this guy right here is 30 degrees, well, don't I know that this whole angle right here, okay, that whole angle should be 120 degrees, right, from over here? So if that's 120 degrees, well, we already got 60 of it. So what's 120 minus the 230s? Okay, oh, 60. So angle X, all right, that measure is just 60 degrees. So notice, think of it like a puzzle. It really is just a puzzle mixed with a little bit of this, a little bit of that, but it's all from the past. All right, so be aware of all that. All right, number 6 is very similar. It's exactly the same. I want you to find X and Y. This is a problem for you to practice. All right, it's a heptagon. How many sides is that? Go ahead and start counting. Okay, and then use your formula just for like number 5. Okay, and then try to solve it. This is the hardest part of your test, I think. So give yourself some time, give yourself some practice, and see how far you can get. All right, you look at number 5 for reference. Okay, guys, so that's the end of the study guide. If you have any questions, come see me, and we're going to get some more practice too. Thank you.